Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 8, in which I will solve some more problems on total probability. Now we solve a problem. Problem number 1. A and B are events such that probability of A equal to 0.42, probability of B equal to 0.48, and probability of A and B equal to 0.16. Determine number 1, probability of not A. Number 2, probability of A or B. Now we solve this. Solution. Number 1. Here number 1, P means probability of not A. Means P A prime. And P A prime means 1 minus probability of A, and this equal to 1 minus probability of A is 0.42, and this is equal to 0.58. Number 2. Probability of A or B. Probability of A or B. Or means union. Probability of A union B. From total probability we know that this is equal to PA plus PB minus P A intersect B. Here probability of A is 0.42. Probability of B is 0.48. And probability of A and B means A intersect B is 0.16. And this equal to 0.74. Now we solve the next problem. Next problem is, let E and F are events such that probability of E equal to 1 by 4, probability of F equal to 1 by 2, and probability of not E and not F equal to 0.25, so that events E and F are mutually exclusive. Now we solve this. Solution. Given that P not E and not F equal to 0.25 implies that probability of not E means E prime and means intersect, not F means F prime equal to 0.25. Let this is number 1 from De-Morgan's law. E prime intersect F prime equal to E union F whole prime, and P E prime intersect F prime equal to P E union F whole prime means 1 minus P E union F. This is number 2. using 2 in 1, we get 1 minus P E union F equal to 0.25, implies that 1 minus, from total probability, this is PE plus PF minus PE intersect F, this equal to 0.25, implies that 1 minus PE is 1 by 4, PF is 1 by 2, minus PE intersect F equal to 0.25, implies that 1 minus 0.25 equal to 3 by 4 minus PE intersect F, implies that 0.75 equal to 3 by 4 is 0.75 minus PE intersect F, implies that PE intersect F equal to 0.75 minus 0.75, implies that PE intersect F equal to 0, implies that E intersect F equal to 5, means null set. Therefore, E and F are mutually exclusive. Now we solve the next problem. Problem is, in a class 11 of a school, 40% of the students study mathematics, 30% biology, and 10% of the students study both mathematics and biology. If a student is selected at random from the class, find the probability that he or she will be studying mathematics or biology. Now we solve this. Let set of students who study mathematics is denoted by M, and set of students who study biology is denoted by B. Therefore, probability to select a mathematics student is 40%, means 0.4. Probability of selecting a biology student is 0.3, because 40% means 40 by 100, that means 0.4. Similarly, 30% means 30 by 100, means 0.3. Also given that 10% of the class study both mathematics and biology, means probability of mathematics and biology is 10%, means 0.1. 10% means 10 by 100, means 0.1. Here, if a student is selected random from the class, now we have to find the probability that he or she will be studying mathematics or biology. means probability of mathematics or biology. That means or means union. We have to find this. Since from total probability PM union B equal to PM plus PB minus PM intersect B. PM is 0.4, PB is 0.3, and this means PM intersect B, and means intersect 0.1 means 0.1. This is 0.6. Now we solve the next problem. Problem is in an entrance test that is graded on the basis of 2 examinations. The probability of a randomly chosen student passing the first examination is 0.8 and probability of passing the second examination is 0.7. The probability of at least one of them is 0.95. What is the probability of passing both? Let the event for passing first examination equal to A and the event for passing the second examination is B. Here given that probability of A equal to 0.8, probability of B means second examination 0.7, and the probability of at least one of them, at least one means it may be first or second or both. That is probability of A union B equal to 0.95. Since from total probability we know that P A union B equal to PA plus PB minus PA intersect B. PA union B is 0.95, PA is 0.8, PB is 0.7 minus PA intersect B implies that PA intersect B equal to 0.8 plus 0.7 minus 0.95, and this is equal to 0.55, and PA intersect B be the both A and B. Therefore, this implies that P, A and B equal to 0.55 implies that probability of passing both exam equal to 0.55. Now we solve the next problem. Problem is the probability that a student will pass the final examination in both English and Hindi is 0.5 and probability of passing neither is 0.1. If the probability of passing the English examination is 0.75, what is the probability of passing Hindi examination? Now we solve this. Now we denote English by symbol E and Hindi by symbol H. Here given that passing English examination, PE, probability for passing English examination is 0.75. Here probability for both English and Hindi, both means E and H, English and Hindi, equal to 0.5, implies that PE intersect H equal to 0.5, and probability of passing neither is 0.1, means probability of not E means E prime and not H, H prime, this equal to 0.1, implies that P E prime intersect H prime equal to 0.1. Since by De Morgan's law, E prime intersect H prime equal to E union H whole prime. Therefore, PE prime intersect H prime equal to PE union H whole prime, and this equal to 1 minus P E union H, implies that this value is P E prime intersect H prime is 0.1, 1 minus. Here we use the formula for total probability. PE union H equal to PE plus PH minus PE intersect H, implies that 0.1 equal to 1 minus PE. Here PE 0.75 plus PH and minus PE intersect H is 0.5. 0.5 implies that 0.75 plus PH minus 0.5 equal to 1 minus 0.1, implies that 0.75 minus 0.5, 0.25 plus PH, this equal to 0.9, implies that PH equal to 0.9 minus 0.25, implies that PH equal to, this is 0.65, implies that probability of passing Hindi examination is 0.65. Now we solve the next problem. In a class of 60 students, 30 opted for NCC, 32 opted for NSS and 24 both NCC and NSS. If one of these students is selected at random, find the probability that number 1, the student opted for NCC or NSS. Number 2, the student has opted neither NCC or NSS. Number 3, the student has opted NSS but not NCC. Here we solve the problem one by one. Let the event for NCC is denoted by N1 and the event for NSS is denoted by N2. That means collection of students who opted NCC is N1 and collection of students who opted NSS is denoted by N2. Here number of NCC student is 30. So the probability for selecting one NCC student, that is PN1, equal to 30 by total student 60. Selecting one NSS student, probability for selecting one NSS student, that is probability for N2, equal to, here number of NSS student be 32 by 60 and both 24. Both means PN1 intersect N2, probability is 24 by 60. Number 1, the student opted for NCC or NSS. Probability for NCC means N1 or N2. That is PN1 union N2. And this is equal to PN1 plus PN2 minus PN1 intersect N2. PN1 is 30 by 60 and PN2 is 32 by 60 and this is 24 by 60 and this equal to 38 by 60 and this equal to 19 by 30. This is number 1. Number 2, the student has opted neither NCC nor NSS, means probability for not NCC means prime N1 prime and means intersection N2 prime, not NSS. This equal to P by De Morgan's law N1 union N2 whole prime. This equal to 1 minus P N1 union N2 means 1 minus 19 by 30 means 30 minus 19 by 30 means 11 by 30. Number 3, the student has opted NSS but not NCC. NSS means N2 but not NCC means N1 not means prime. P N2 intersect N1 prime. This means P N2 minus P N2 intersect N1. We know this formula from our previous video lecture. This equal to PN2 is 32 by 60 minus PN2 intersect N1 24 by 60. This is equal to 8 by 60 means 2 by 15. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.